Welcome to Chapter 5. It's ratios and rates, and I've listed out here the different sections we have. The way we're going to do this chapter might be a little bit different than what we've done in the past because there's so many sections. So we're going to start off with, we're going to start off with 5.1, which is ratios, and then this will be a video, and then we'll go from there, and I'll kind of let you know what we're doing as we go. So let's start with ratios, and we're starting on page 192 out of Big Green. 5.1's lesson. So to start our lesson 5.1, our key idea is a ratio, and that's our key vocabulary for this lesson. So a ratio is a comparison of two quantities, and we talked about, well, I think in at least a couple of our classes, we talked about quantities meaning a number of something. So ratios can be part to part to whole, or whole to part comparisons. And I'm going to show you in examples what I mean. And again, I'm taking this right from, what is it, page 192. Just if you want to follow along and can't read my drawings that I'm about to do. I'm going to draw some crayons here in just a second. So that will help you with your examples. Okay, so I was going to draw them, and then I started drawing them. They looked ridiculous. They didn't even look like crayons. So I started over and I took a picture. Sorry for my horrible drawing that it didn't even look like a crayon. It was bad. So I'm going to start off with a couple examples. So first example would be, the first thing that you start off with is counting. So I've got 2 red crayons, and then I've got 1, 2, 3, 4, 5, 6 blue crayons. So knowing that I have all that, that's what we can start writing out our examples in our in the actual ratios that we're going to be talking about. Let me get this erased really. Oh, I've got it set on a. Sorry. There we go. That was a little bit quicker. If I stop the video, it won't let me erase anymore. That's why I'm still talking. So my first one I can start off with is saying 2 red crayons. 1, 2. 2, as in T-O. 6 blue crayons. 1, 2, 3, 4, 5, 6. So this first example is showing me that there's 2 red crayons for every 6 blue crayons. This next example is showing that there's 1 red crayon for every 3 blue crayons. Well, if you look at my ratio of how I have it, every 1 crayon I have, there's 3 blue crayons. 1 red crayon, 3 blue crayons. My next example is saying that there are 3 blue crayons per 1 red crayon. So these are all keywords that we can use when we talk about ratios. Here's another one. 3 blue crayons for each red crayon. My next one down here says 3 blue crayons out of every 4 crayons. If you look at the meaning of that one, if I've got 3 blue crayons, there's a total of 4 of them up top here. Got 3 blue crayons, a total of 4 of them on the bottom, so that does hold true. And my last one, I can say that there's 2 red crayons out of 8 crayons, meaning 8 crayons total. So as you can see, there's lots of examples. I could probably go on a little bit more, but I'm going to stop there, and then I'm going to write it out as algebra, what it would look like. So if we're writing this out as algebra, it says the ratio of A to B can be written as A, and then when we have our 2 dots like this is meaning the word 2, so it means A to B. And you'll be seeing that a lot when we're doing ratios. So for example 1, when we're writing ratios, the book shows on page 192, so we have the coins that are shown. So A says write the ratio of pennies to quarters, and this is what it would look like. So if I'm going to count up all my pennies, obviously my pennies are the ones that have the P on them. 1, 2, 3, 4, 5, 6. So I know I have 6 pennies. And then it says to quarters. So those are obviously the ones with the Q on them. 1, 2, 3, 4, 5, 6, 7. To write out that ratio, if I know I have 6 pennies and 7 quarters, I would write it like this. I could say 6 to 7, or 6 my 2 dots, 7. So I have 6 to 7 quarters. Every 6 pennies I have 7 quarters. So this next one, I'm writing the ratio of quarters to dimes. So we already know from before that I have 7 quarters. I don't have to recount those. But we have to figure out how many dimes do we have. And obviously they're the blue ones that have the D on them. 1, 2, 3. So I can write that information, and I know I have 7 quarters and I have 3 dimes. So it would be, if I'm starting with quarters, I would put how many quarters I have first. 7 quarters to every 3 dimes, or 7 to 3. Those are dots. And my last example for C, is write the ratio of dimes to the total number of coins. So we already know how many dimes there are because we did it in the last one, and we've already counted them. So we have 3 dimes, but this one says to the total number of coins. So all total. So you count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's a total of 16 coins. So that means we're starting with dimes. That's what was said first. So there are 3 dimes to 16 coins, or 3 to 16. At the bottom of page 192, there are 2 on your own problems that I will do at the very end of the lesson. So I will go through those. So if you want to get some more practice on those, I'll have those written out at the end. So here's another vocab term for you, tape diagram. So a tape diagram is a diagram that looks like a segment of tape. It shows the relationship between 2 quantities. And in example 2, that's what we'll be talking about, is using a tape diagram. So to start example 2, using the tape diagram, they give us the word problem that says the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowances total $40. How much is each allowance? Meaning, so you're doing chores, you're getting a monthly allowance. So basically, I'm going to help you visualize the problem using a tape diagram. So to start off, you're going to express the ratio 5 to 3 using that tape diagram, and you're going to start with you, and then you're going to also have we'll do your friend in the red color. So your friend. So we're going to draw 2 tape diagrams here, and we're going to get out and figure out what our parts are. Okay, so now that I have my tape diagram in here, let me explain why I have them split up like this. So first of all, let me get a different pointer here. So first of all, I've got, I'm looking at what my ratio is. It's 5 to 3. I'm talking about monthly allowance. So I split up a tape diagram into 5s. 1, 2, 3, 4, 5. And then my friend has 3 parts. 1, 2, 3. I know that's kind of hard, so I'll do it like this. 1, 2, and 3, because we're talking about your friend's ratio and your ratio. So that's your allowance. So basically, I'm saying that I get 5 total parts of the allowance, where your friend only is getting 3. 5 to 3. So now what you do is you say the 8 total parts, because I've got 1, 2, 3, 4, 5, 6, 7, 8. So between both of these, I have 8 parts. And that's comparing our total. School's out. That's comparing our total amount of parts that represents the total of $40, which is what they told us up here. So how much is each allowance? Well, if I know I have a total of 8 parts, that means that 1 part must represent the total of $40, which would be our 40 divided by 8, which equals $5. Now, before I lose anybody, I want you to think about this. So again, let me get my pointer. the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowance is total $40. How much is each allowance? So if I have 5 parts, which is what they told us right here, 5 to 3, and my friend has 3 parts, I have a total of 8 parts representing a total of $40. That's when I took my $40, I divided it by my total of 8 parts, and I come up with $5. So that must mean that this equals $5, this equals $5, this is 5, 5, 5, 5, 5, 5. So we want to know what is the amount of each allowance. So this must equal 5, 10, 15, 20, 25. And this one must equal 5, 10, 15. And just to make sure, 25 plus 15 does equal 40. So that means your monthly allowance, you get $25 per month, while your friend gets $15 per month, and that would be your total answer for a problem like this. Okay, so we will there will be a on your own part to this if you need a little bit more help towards the end, but review it if you're a little confused, because it can be confusing. So example 3 is using a tape diagram. I just want to do a little background before this, because I remember doing this with my kids last year and them getting confused. First of all, we're dealing with, this is talking about garlic. And when you buy garlic, you buy it usually in a bulb like this, and then you can split it into cloves. So a little bit of background knowledge about bulbs and cloves might be a little helpful. You can also take these cloves and plant them in the ground and grow new garlic bulbs as you go. So that's what this one kind of deals with. It's kind of cool because, you know, a lot of you might not have known that about garlic, because you maybe buy it when you buy it at the store, or your parents do it in spices or minced or something. But this is how it looks when it's completely grown. That's usually how I buy it. So anyway, you separate, the story problem says you separate 42 bulbs of garlic into 2 groups, one for planting and one for cooking. You will plant 3 bulbs for every 4 bulbs that you use for cooking. Each bulb has about 8 cloves in it. About how many cloves will you plant? So that's what the question's asking. Let's set this up using a tape diagram to help visualize it, and we'll express the ratio 3 for every 4 using a tape diagram. So this is what our ratio will look like. It would be 3 to 4. So you're planting every 3 bulbs for every 4 that you'll cook. Okay, so I'm going to start here with, I've got my planting and I've got my cooking tape diagrams. We got to figure out what each of these parts equal along the way. So to do so, you have to count how many parts you have. So we've got 1, 2, actually I'm not going to write it that way, sorry. We have 1, 2, 3, 4, 5, 6, 7 parts. Now, you have to go back into your story problem and do some reading. So if I know I have 7 parts that represent, how many bulbs? Well, we have to go back up here. It says you separate 42 bulbs of garlic into 2 groups. Well, here's our 2 groups, our planting and our cooking. We have 7 parts total that represent our 42 bulbs. So each part represents 42 divided by our 7. So here I'm going to write as I go. So 7 parts represent 42 bulbs. So that means each part represents 42 divided by 7. So just in case I lose anybody, let me tell you where I'm getting this information. I've got my 42 bulbs because of right here. I separated them into 42 bulbs. There's 2 separate groupings. My grouping is one planting, and my other one is cooking. Planting, cooking. I've got 3 parts for planting, and I've got 4 parts for cooking, which is where I got my ratio from. So my 7 parts represents 42 bulbs. Each represents 42 divided by my 7. I'm getting my 7 because of my total number of parts, which means it equals 6 bulbs. So that means this equals 6, 6, 6. This one also equals 6, and so on. So each one of these represents 6 bulbs per part. So let's start with our planning. There are 3 parts times our 6 bulbs, which should give me a total of 18 bulbs for planting. And for cooking, there are 4 parts for every 6 bulbs, so we should have 24 bulbs for cooking. And all I did was I took my number that I have total of parts and I multiplied it by the amount of bulbs in each of the parts. Okay, so the group, if we've got 24 bulbs for cooking, the group of 18 bulbs has about, I'm going to go back up here and show you, each bulb has about 8 cloves. How many cloves will you plant? So we're talking about planting. That's what we're trying to figure out here. So if each of these bulbs, remember a bulb is this portion right here in my picture, how many cloves do I have total? That's what the question's asking me. So I got to do a little converting. So the group of 18 bulbs has about 18 times 8 to give us a total of 144, and we're talking about cloves. Sorry, I'm running out of space here. Write it up there. So how many cloves will you plant? You will plant 144 cloves. And remember, the difference between the cloves and the bulb is this. Now, this is a pretty tough question example. It's giving us a lot of different information. We had to do a little bit of converting. So yes, it is a little bit tough. We had to go back from bulbs to cloves, and again, they give us, we're dealing with garlic, so it's kind of confusing. I get that. But if you have trouble with this and you're still a little bit skeptical of it, I want you to rewind. I want you to go back and see exactly where I got these parts, where I got the bulbs, where it was all coming from, or go back into your book on page 193 and really review it. So 5.1, your practice problems for your twirl discussion are big green, page 194 to 195. You have numbers 7, 9, 11, 13, 15, 16, and 19. Please make sure that you're really working hard to solve these. The first few are very simple. That's why there are more than usual. And then also, if you are interested in gaining a ticket, if you come to me with the correct answer to number 18, then you will get a ticket. Do you have to do this one? No. Only if you want to earn a ticket. You have to have the correct answer in order to get the ticket. So be very careful on this one. It's a little tricky. And good luck. The next couple minutes, well, it might be a lot of minutes, will be over the on your own problems. So stay tuned if you want to do that. If not, I think you're at about probably close to 19-20 minutes on the whole video. The rest of it will be additional time. Good luck. So the on your own numbers 1 through 4, we'll start with number 1. It says in example 1, write the ratio of dimes to pennies. So if this is my picture and I just took a screenshot and resaved it, these are the coins that we had shown. All you would have to do here is say, all right, well, how many dimes do I have? How many pennies? So dimes, we have 1, 2, 3. So I would write 3 dimes. And then pennies, we have 1, 2, 3, 4, 5, 6. So my ratio would be 3 to 6, or you could also write it like this, 3 to 6. So we'd have 3 dimes to every 6 pennies. So on this one, it gives you a picture that looks like this. This is number 2. I'm on page 192. It says the circle graph shows the favorite toppings of ice cream of several students. Use ratio language to compare the number of students who favor peanuts to the total number of students. So when you look over here, let me get my... okay. When you look over here, we're dealing with peanuts, right? So we have 5 students who favor peanuts. And so we're going to use that as our first ratio. So 5, kind of going back to what I was doing in the other problems. 5, now I need the total number of students. So in order to get the whole total number of students, you have to add up all these numbers. So let's start. We've got 9 plus 1. That gives us 10. And then we have 5 plus 9, we know equals 9. And 10 plus 9 equals 19. So we know we're dealing with a total of 19 students. So our ratio in ratio language would look like this. So the question again says use ratio language to compare the number of students who favor peanuts to the total number of students. So we have 5 to 19. And you could also say it like this. 5 out of 19 students favor peanuts. You could say like as a topping or just leave it at that. So this would be what I would expect an answer to look like on a question like this. So number 3 says, in example 2, so now I'm on page 193, the ratio is 2 to 3. How much is each allowance? So before it was 5 to 3. So you have to redo a chart for you, or I'm sorry, not a chart, but a tape diagram for you and then for your friend, where you have 2 parts and your friend has 3 parts, but the total is still $40. So let's see what we come up with. So we're going to first start with adding up our total amount of parts we have. So if I have 2 and your friend has 3, or you have 2 and your friend has 3, that gives us a total of 5 parts. And our 5 parts are representing the $40. So if that's true, then we could say, how much does 1 part equal? Well, $40 divided by each part of 5 equals 8. So that means each part equals $8, right? So this would be 8, 8, 8, 8, 8. So if we added all that up, 8 times 5 is $40 total. So to find out what we make, how much money we would get as an allowance, we would say we've got 2 parts times our $8 each, and we should come up with $16. Our friend, so this is you, your friend has 3 parts times 8, and your answer should be $24. And if you do the math, 24 plus 16 does equal a total of $40. So your answer would be you make $16 for each month for your allowance. Your friend has $24 each month for allowance. And I've also decided I'm not going to do number 4. I'm going to go over this one in class because I think it's a little bit more difficult. So I will be reviewing on your own number 4 as a group. So this ends our first video, and remember, come with questions, so if you have any questions, to let me know.